Hello, everybody. Um, a few things about me. I was born in Romania, as Ricky said. I've been doing some system development, especially like C++ networking. So I started from a really low-level code. Then I went into the databases, studying databases on how they work and how they are built. And then later on, I moved on into the web development part. So people will call me a full-stack developer, even though that will remind me of my old days when you'd get a Stack Overflow error. Yeah, I've been spending 3.5 years in Copenhagen, where I did my master's in software engineering and focusing on databases. And I was working as a freelance consultant, well, as a web developer for a company full-time. And then I was a freelance consultant for some of the startups that you can see there on the bottom, doing some house automation for the niche industries, or taking really early startups, giving them advices, especially startups that they wouldn't have yet a technical person in their teams. So there would be just a bunch of guys having an idea, and they would like to know how to build it, and they will just come up, and you would talk with them and explain them what they can do and what they cannot do. So today I'm going to talk about Volt, which are a bunch of awesome guys that they created some chargers. And so basically the idea is that you are at a concert, a festival, you are somewhere out of nowhere, you are camping, and then you would want to have your phone charged. And they just provide a portable charger like the one in the picture. And as part of the package, they also provide a custom cable, so it would work on every phone. And they will have stations in the festival place where you'd be able to swap your charger when it's empty with a different one, with a fully charged one. So usually you would buy a package, which would mean 5 charges or 10 charges, and you'll get by post before the festival one of the chargers, and then you will use it, and then you'll just go and swap with a newer charge battery. So yeah, and they also had portable stations, so they would just go around the people, around the campus, and just try to find the customers or swap the batteries of some of the customers. Yeah, this is how their interface was looking like when they launched in the first year. So you basically would search a customer by phone number or by his name or by his email, and then you would land it to his profile, where you'd see what kind of a service he has and how many swaps he did, how many he has left, and you'll have a button just to swap it. So this is like the interface that was used by the actual guys operating in these stations, the charging stations. And the problem is that it will take 4 or 5 minutes to serve one sober customer. So at some point, that would be increasing slightly. And people in a festival want to listen to music and drink beer, and they are okay for queuing for a beer, but they're not okay for queuing for charging their batteries. So the whole idea was, how can they make it that it's faster, and how can they serve the customers, make them be satisfied and serve things faster. So we came up with the idea to put an RFID tag in every battery, so every battery will be uniquely identified, and then you will have the customer battery, so you'd have kind of a link between, what battery a customer has, and then you would identify the customer directly. So basically that will mean that you'd have to notify somehow your application when you would scan a new battery. And there are 3 kinds of notification, as I'm pretty sure most of you know. You have client-server notification, in the terms that the client is just going to, so this browser, this interface will just kind of poll or ask, hey, did you read the scan? Did you scan something? Did you scan a battery? Or there's a long poll where your client will just ask the server, hey, are you reading some batteries now? And then the server will just respond at some point. Or you'd have push notification, which is mostly for mobile. We've used Socket.io. I'm not sure how many of you have used Socket.io. It's a JavaScript library that works both on the client and then on the server on Node. And it's actually using WebSockets, but in case your browser doesn't support WebSockets, it's just going to fall down to like a long polling using Ajax. So it kind of abstracts everything. You don't care about how things are happening. You are just having a mean of communication in real time between a server and a browser. And yeah, this is an example of a simple Node.js server where you would just create the server and then you would say, I accept the connection, and if I get a message, I'll just broadcast it back. So this is actually an example of a broadcast server that you would be able to connect. You would send something to the server, and the server would just send something. It would broadcast to every client that is connected. So it's as simple as that in Node. And then a client, it's something like this. So you would just connect to a server, and then you would just send a message using the send command. Their existing system was built in CodeIgniter with MySQL, and they had like a REST API because they thought, okay, we're going to make this interface being faster, and we'll put Ajax, and then everything is done. But actually, it didn't happen, right? So yeah, but that was their way of making things going a bit faster. And then what they wanted, because it was a startup, and they just used their system in some festivals, and then they wanted to be able to fall back to their old system always. So what we had to do was just to extend their system with these RFID readers, but in case the readers are not working or something goes south, they would just be able to go back to their own system. So yeah, we ended up extending their system to look something like this. And why is it like this? First of all, we tried to make them move entirely to Node, so that's why we separated the Node server. We just made a Node server there. But also, one of the reasons is that a portable station would not actually have the Node, like the actual CodeIgniter and the Node server connected, so that will be separated. So a portable station will just have the C part for the readers and a client that will communicate to a server some of the data, and then the server will just send it to the browsers. So yeah, and we made we used the libNFC, which is like an open source NFC reader library, which is like the worst possible, and we used it and we tried it to have multiple readers, because in this kind of a station you would have 3-4 guys serving, so you'd have 3-4 queues. And then the way we made it was that you would have a child process for this reader for every single guy that is sitting there. So every reader would have its own C child process, and that will just read the data, and then it will actually send it to the parent process using C pipes, where we would have some kind of a concurrency checking. So you would not, if 2 guys are scanning at the same time, you're not going to get different stuff. Then the C will communicate with the node, our small node client that was living there with the readers using TCP sockets. We tried doing some kind of invoking directly, but it's a bit more messy in Node to actually invoke a function or invoke a library. So we just made a TCP connection between the C code and the Node client. The Node will just propagate it to the server, and the server will propagate it to the browser. So in this way, you will actually get data live. When you would scan a battery, you would get all the data live from all the C code all the way back to your browser. The browser will make a request to the server with the tag ID. The server would know that the tag ID belongs to a certain customer, and will just respond you and redirect you to the actual page of the customer. So then the way you would operate, you would scan the battery, you'd run it to his page, you'd say, you'll press swap, you scan the battery again, everything will propagate again, everything will be called in the backend, so you didn't have any interaction, but scan a battery, press swap, scan the next battery, and everything gets done for you, and you just hand it to the customer, and that's it. So we basically got to reduce the serving time drastically. We also have a restart data flow, because sometimes if you would unplug a battery, like one of the readers, or you spit some water on it, it might fail, so you have some issues there, and if you unplug one of them, all of them would fail. So we made a restart functionality for them. So from the Node client, you would be able to just say, OK, I want to restart my server now. And then the browser would send to the server a restart command. The server will just propagate it to the Node client. And the Node client will actually make a restart on the C code. The server, it is almost as simple as the one that I just showed you. So it's very simple. You get a command. You are listening for a send command, and then you send a message to the browser, or you get a do restart from the browser, and you just send a restart to the client. The client looks something like this. This is the part that is actually doing the restart. So you'll just kill the parent and then all the child, and then you'll just restart it back. And the part of the code that works with C would be something like this. So you just actually listen to some data on some port that we just come up with. You would parse this data, make it a JSON format which will have like the user, like the UID, which is the actual tag ID of the battery, and then a reader ID, because you'd have to know which reader has been used in order to know in which of the browsers to display it. And then here would be like, how do you know in the beginning which reader is which? Because sometimes the IDs were changing. So in order to actually do that, we gave them the opportunity to, they will open their browser, they will connect to the server, you would scan a battery to one of the readers, it will show you what reader would be, and you would say, OK, I want to listen to this reader now. And then you will see only the messages from that reader. And then you would scan on the next reader, and then you would kind of identify each reader, and you'd be kind of binding one of your laptops or one of your tablets to listen only to, or to display the messages only from one of the readers. Yeah. So the backend, we are not allowed to touch the backend. That was the rule. So what we ended up was just extending it. So what we actually did was just to create a new table in their database model, which will have the battery, tag ID, the customer ID, a state if it's out or in, so you would know if the battery has been given or not, so you can be able to get some statistics, how many you have out, how many you have in, and so on. And then you have created like just a timestamp when it actually happened. And then we'll not do any deletes on this table. We were just making inserts, so you'd know about, according to the state, exactly what, if he gave it to you or not. So they will actually be able, at the end of the festival, to get some kind of information of how many people actually swap the batteries and so on. So kind of a business intelligence using our table combined with their own informations. And then we just made 2 REST methods for that. So we extended their API with 2 REST methods. One was to create a record, and one was to actually get a customer using a RFID tag ID. Yeah. And as a summary, they reduced the time per client from like around 5 minutes to under 30 seconds. So actually, sometimes it was just a couple of seconds, like the guy would come, and if it would be actually really empty, he would just in 2 seconds, and the customer was just amazed how fast that is. They were using 6 RFIDs per station. That was like the maximum that they tried it. They even had these portable stations, like somebody with a bike, just going around and trying it, and the communication was still going because they would have their mobile, they will have a public IP, and they will just do it over the internet, or they will have just maybe a big access point on Wi-Fi on that concert, and they will just do it. And they were using Ubuntu that we tried, which means like all the Debian-like systems would work, I guess. And they actually tried it with Raspberry API, like with the Raspberry Pi, so you'd be able actually to walk with a Raspberry Pi that is connected to the internet and a reader and just do this thing. So yeah, that was pretty awesome. Yeah. That's it. Thank you.